Now, surface area of prisms and cylinders. The surface area of a prism is 2 times the area of the base plus the perimeter of the base times the height. 2 times the area of the base plus the perimeter of the base times the height. And let's go back and make sure we understand why. If I look at this figure, this triangular prism, I have 2 bases, so I'm going to have the area of the base times 2. And then what I end up having is, remember that the perimeter of the base ends up showing up in each of these rectangles. So if I split these up, the perimeter of the base, um, this one would go with this side, this hypotenuse looking thing would go with this side, and then the shortest side would go here. So all of these match up with one of these squiggly lines, which ends up being the other side of the rectangle. So P times H, perimeter of the base times the height, is actually just a way of simplifying finding all of the areas of the rectangles. Because remember, in these problems, the lateral sides are usually rectangles. So this is actually just a shorter way than finding the area of each individual thing. If you can get this formula down, you're going to end up making your life a little bit easier. So 2 times the area of the base plus perimeter of the base times the height. The surface area of a cylinder is similar, and actually when I teach my class, I actually teach them to do the exact same thing. 2b plus pH. So any 2 base figure, any 2 base solid, has the exact same basic formula. 2 times the area of the base plus the perimeter of the base times the height. Now in a cylinder, I can actually break this down a little bit more. The area of the base in a cylinder is pi r squared because it's a circle. And the perimeter of the base is actually what we call the circumference of a circle. And the circumference of a circle, the formula is 2 pi r. So I would have 2, b is actually pi r squared, plus the perimeter of the base, which is 2 pi r, times the height. But that's a little confusing to memorize. So if you just know these from your past experience and you memorize this formula, you can just sub those in instead of having to memorize more formulas. Then h is the height of the solid. Okay, let's do a few examples. First problem, we have a right triangle. This hypotenuse is 25. One of the legs is 7. So in order to find this side, I need to do the Pythagorean theorem. So 7 squared plus, let's call that x squared, equals 25 squared. Then in the interest of time, I'm just going to give you what that is. It's 24. So x equals 24. Now, the simple method, I kind of forgot to put that on the screen, but the simple method to find the surface area of any simple 1 or 2 base solid, find the area of the base. So that's the first thing we want to do. Then find the lateral area. The lateral area is actually whatever is not included in the base part of the formula. So for 2 base figures, pH is what's called the lateral area. So in these problems, this is going to be the lateral area. So that's what we're going to find next. And then we find the surface area by adding everything up. So the area of the base in this problem is going to be area of a triangle, 1/2 base times height. So 1/2 times 7 times 24. And note that we can use area in a variety of different, or base in a variety of different ways. So when I say 1/2 base times height, I'm not referring to the shape of the base. I'm referring to the base of the triangle, which is 7. So 1/2 times 7 times 24 gives me 84 inches squared. Then I need a perimeter of the base. So 7 plus 24 plus 25, that's 56. So then what I'm going to do is 2b plus pH. So that's 2 times 84 plus the perimeter of the base, which is 56, times the height. Now the height is 30, and so this is really important. Remember, in a triangular prism, it's important to know that this shape is my base, and so that means since that's my base, I have to act like that's on the ground. So mentally put that on the ground and figure out what would the height of this figure be. The height of the figure would be the thing that's the same in every rectangle. So that is each of these. Like if I stuck the triangle on the ground, this height would be what I see. So the height is 30. So it's 2 times 84 plus 56 times 30, which is 1,848 inches squared. Problem 2. I have a rectangular prism. I can actually choose a variety of different ways to do this, like we talked about. I can make whatever I want the base. Now, visually, I think it's probably easier to just make whatever they put on the ground the base if you have a rectangular prism. So I'm going to make these shapes the base, and then we'll work from there. So if top or bottom is the base, then the area of the base is 7 times 8, which is 56 centimeters squared. Perimeter of the base is 8 plus 7 plus 8 plus 7, which is 30 centimeters. Notice that perimeter is not an area, so that's just centimeters. Then I need the area formula, which is going to be 2b plus ph. So 2 times 56 plus 30 times 21. So notice that the height is 21. That's the one thing that I haven't used yet in this problem. So 2 times 56 plus 30 times 21 is 742 centimeters squared. Also note that if I did this exact same problem using the front or back or left or right as the base, I've already written it down. But if I did it either way, I would have got the same answer um, that I got when I did the top and bottom as the base. So you actually do have a choice when you have a problem like that with the rectangle. Okay, now we're going to have an octagonal base. So if I stick the octagon on the ground, notice that all of these sides that are 35 meters would all be sticking up in the exact same height. So that means that in this two base figure, the octagon has to be the base. So since the octagon is the base, I'm going to find the area of the base. And that means I have to remember how to find the area of a regular polygon. So I have a triangle, and I'm going to redraw the triangle over on the side. So this is a height of 9. Now, in order to find the area of a regular polygon, I need to do 360 divided by the number of sides. An octagon is 8 sides. So the central angle is 45 degrees. And then I do the apothem split. So 45 divided by 2 gives me 22.5 degrees. So this angle is 22.5 degrees. And then I need to find this length in order to be able to find the area of the right triangle or the octagon. So tangent of 22.5 equals x over 9. Multiply the 9 over, so 9 times the tangent of 22.5 equals x. That is 3.728. Then I multiply that by 2 to get the whole side length, which is 7.456. And I'm keeping these numbers in the calculator all the way. So I'm not rounding until the very end, but on paper, I'm just going to round a little bit. So the area of the base is 1/2 base times height for the triangle times the number of triangles. So remember, we will have 8 triangles here. So 1/2 times 7.456 times 9, because the height of this triangle is 9, times 8. So that ends up being 268.410 meters squared. Then the perimeter of the base is going to be 7.456 times 8. And that ends up being 59.647 meters. So the area is 2b plus pH. So 2 times the 268.410 plus perimeter of the base, which is 59.647 times the height, which is 35, because if I stuck this octagon on the ground, the height would end up being 35. When I add all these things together, I get 2,624.457 meters squared. And I typed this into the calculator exactly, and that's what I got. And then if I rounded things and then typed it in the calculator, my answer would be slightly different. So it's kind of important to understand that the more you round, the more it's going to be off. If I rounded it to 1 decimal place, it would be off even more than if I rounded it to 3 decimal places. So just keep that in mind. Now, real quickly, some cylinders. The area of the base here is pi r squared. So we have 49 pi inches squared. Then the perimeter of the base, remember the perimeter or the circumference of a circle is 2 pi r. So that's the perimeter or circumference of a circle. So that's 2 times pi times 7, which is 14 pi. So the area is 2b plus ph. So 2 times 49 pi plus 14 pi times the height, which is 19. And so this ends up being 98 pi plus 14 pi times 19. And that ends up being 364 pi inches squared. If I wanted a rounded answer, I could type that in the calculator, 933.663 inches squared. For the one on the right, remember, even though it doesn't look like the circle is on the ground, I would probably want to think about it like the circle was on the ground. And then in this problem, notice that they gave me a diameter. So I want to make sure that I understand that the radius is 3. So the area formula, the area of the base is pi r squared. So pi times 3 squared, that's 9 pi. The perimeter of the base is 2 times pi times 3. So the radius is 3 in this problem. So that's 6 pi. So I have 2b plus ph, which is 2 times 9 pi plus 6 pi times the height, which is 8. Notice that this would be 8 if I put that circle on the ground. So that's 18 pi plus 48 pi, which is 66 pi. And if I wanted a rounded answer, I would get 207.345 centimeters squared.